move on to the concept of food webs. What are they? Before we have a web, it's important to notice that we have a food chain. And each link in a food chain is known as a trophic level. Here are two examples. We have a terrestrial example of a food chain and an aquatic example. The first level, the primary producers, these are the first trophic level, and the primary producers are eaten by the primary consumers. This forms the second trophic level, and the secondary consumers eat the primary consumers. That's the third, and it goes on and on and on. You can have many links in the food chain, but you must bear in mind that the food chain basically represents the transfer of energy. So we don't want too long a food chain, because that means that the top trophic level will not receive enough energy. And essentially, the energy that we are using in this food chain comes from the sun, and obviously it is used by the plant during photosynthesis to create its own food, and that is then passed through the chain. You will notice that it's actually a full circle of life and energy, because it doesn't end off with the hawk. Once the hawk being the top trophic level, or the apex predator, the carnivore, no one's going to eat him, but he is eventually going to die. And when he dies, there will be decomposers that will then turn that dead body, decomposed body, into nutrients, which is again used up by the plant during photosynthesis. So obviously in reality it's a much more complex situation. Instead of just having these simple food chains, we have food webs. And the food webs are basically a series of overlapping food chains, and they represent the connections that we see in an ecological community. So this is basic biodiversity. It's the variety of life forms and all their interactions with each other. Okay, so why are food webs important? Well, let's look at another concept known as ecological stability. There are two types. The first is resilience, and this describes the ability of a system or community to return to its original state after it has been disturbed. So in other words, it's able to recover quickly after disturbance. And then we also have resistance, and this describes the ability of a community to avoid displacement in the first place, i.e. to remain essentially unchanged. So it turns out that there's a relationship between food webs and stability. So for instance, if we increase the complexity in a food web, so there's more overlapping food chains, this actually makes the community more resilient, which is good because it makes it more stable. So if we look at the example of this simple food chain with the grass, the rabbit, and the fox. Say for instance, we want to start hunting rabbits in the wild and selling them as pets and eating them, blah blah blah, and the population decreases, it declines. So we wipe out the rabbits. If we do wipe out the rabbit, it's fine, because the fox can still eat on the squirrel and the mouse and the birds. So you can see how this community is still stable, even though one of the levels or the consumers have been removed. Okay, so to check your progress, see if you can answer this question.